welcome back everyone. My name is Dhanyashri and today we shall be doing a simple 4-bit unsigned multiplier on the DE1 SoC Altera Cyclone 5 Triassic board. First, we shall start by creating a brand new project. Now we have our multiplier project created. We're going to go to the right side of the board. It might be different for you, but for me it's on the right side. Here we're going to go to basic functions, arithmetic, and we're going to choose LPM mult. Here we can give a name for the multiplier. I'm just going to be giving it multiplier underscore 4 underscore default, and I'm going to click on OK. This gives us another pop-up menu where we can decide where we should design the multiplier. Here we change the width of the data input A and data input B to 4 and 4 bits, and it automatically creates an 8-bit output. We click on next. We do not change anything in this tab. Over here we leave it as default, the optimization to default. Here we click on generate netlist. Next. In the last final page, we click on the creation for mult4 .cpm file or the visual component for declaring file, and we click on finish. Here, when we go to files, we should have the .qip folder, which also has our default which also has a multiplier.v file. Here we should make this as a top level entity and we compile it. As we are done with the compilation, we should now open the pin planner. This is our DE1 SoC Cyclone 5 Altera board. For this experiment, we should be using these four switches, that is SW0, SW3 for data A, and we shall be using SW6 to SW9 for data B. So these four and these four. We should also be programming the LEDs starting from here, LED 0, all the way up to here, that is LED 7. Here in the pin planner, we have to assign data A 3 down 0 to switches 3 down 0 and data B 3 down 0 to switches 8 to 6. You can start assigning the pin values here. Pin underscore AF10, pin underscore AF9, pin underscore AC12, and pin underscore AB12. Here, data B, pin 3, will be pin underscore AE12, pin underscore AD10, pin underscore AC9, and pin underscore AE11. Now the result outputs will be assigned to LED pins 0 to 7, as it is a 7-bit output. LED 7 will be pin W20, pin underscore Y19, pin underscore W19, pin underscore W17, pin underscore V18, pin underscore V17, pin underscore W16, and finally pin underscore V16. We can save this, close this, and we should recompile the entire program again. As this is done compiling, we can go to the program device, delete this, auto detect, Here we should add our configuration file. Check it for program configure, and we can now send this netlist onto our FPGA board. This is the fully functional 4-bit multiplier using LEDs. Here we can observe that these 4 bits as well as these 4 bits are 0, hence we don't have any LEDs flashing. But when we start giving values, it starts showing the LED. Here we can observe that it is 2 into 2, that will be equal to 4, or 2 bit 10 into 2 bit 10, that will be 4 bit 0100. We can go and see what it would be like when we turn all of them on, and with variations we can observe that not only does the multiplier work, but it works as expected. That is it for this video.